Good morning. I'm going to show you how to do the first simulation that you'll be doing today in class. And first you'll need to go to this web address listed on the top of your worksheet. When you get there, click on Run in HTML5. That way I know for sure it'll work on all your devices, even iPads. When you get here, you need to click on Acceleration. Double click on it actually, and here it is. So you'll look at your worksheet, and I'm going to go over scenario 1. The first thing I want to show you is here it says check all the boxes in the yellow area in the upper left. Here we go. Sum of forces. We want it to show us the net force. That means net force. Numerical values. The masses of the object. The speed of the object. Show us the acceleration of the object. Now it says choose a brown crate. We already have one. And hint, hint, we're using crates for all of these, so don't worry about the refrigerator. And then it says set the friction to none. So here's the bar that says friction. Set it to none, and you see, oh look, it turned to like an icy ground because ice is what we often associate with very, very low or no friction. Next, and finally, it says set the applied force, force of the person, to 100 newtons. Here's the applied force. And just click this to 100 newtons. And you'll see it's slowly increasing in speed. The applied force is 100 newtons and the net force is 100 newtons forward here. And you see there is some acceleration here as well. Alright, and we'll keep watching it. And there you go. So, what we want you to do, I'm just going to reset this, now is to draw a free body diagram for the crate during the speeding up process. Not when the man falls down, just right now for the speeding up process. Alright, and so I have helped you out there. So here is the section on your worksheet called Quantitative Free Body Diagram with a net force arrow. This dot represents the crate. What forces does the crate feel when that 3D man starts pushing it? Well, gravity in the downward direction, normal force from the ground, and these are the same size because the crate isn't moving up or moving down, it's moving to the right. So that's the applied force from the man. Let's label these real quick. That's 100 newtons. We set the applied normal force from the person. And then here is the gravitational force and the normal force. How did I get 490? Let's review that. We'll use the Fg is equal to m times g equation from first semester. So the gravitational force that the crate feels from the earth is equal to the mass of the crate times 9.81, and that's how I got 490 newtons. You need to, on all the rest of the simulations, you need to have quantitative free body diagrams just like this. Oh, and here's the net force arrow. Apologies. There's no friction here because we set the friction to 0. And the net force, just like we talked about last class, in the y direction is 0 because this is 490 and this is downwards, so it's going to cancel out this 490. So the only net force we have going on here is just 100 newtons to the right. If you missed last class, buddy up with someone that was here. They should be able to share with you their perspective on how I got 100 newtons for the net force as well. Alright, so the next one you should do in all the simulations is find the acceleration after you do the free body diagram. And that's that equation we talked about last class as net force is equal to mass times acceleration, Newton's second law. So we're going to use the mass of the crate and the acceleration of the crate.
Good morning, Sacred Heart Cathedral. Please join us for morning prayer in the chapel beginning at 7:40. All students, faculty, and staff are welcome. Thank you.
Ooh, all right, so I plugged in 100 newtons of net force from our free body diagram, set it equal to 50 kilograms, that's the mass of the crate, and I'm going to solve for the acceleration of the crate by dividing, and I'll get 2 meters per second squared. And if you're wondering how the units worked out, that's there for those of you that are interested. All right, written description of the motion is here. And how do you do the quantitative velocity graph? Well, the crate wasn't moving, so we're going to put a point at 0, 0. I know that the acceleration is 2 meters per second, which means the slope of this velocity graph has to be a positive 2 over 1. So you're going to go up 2 over 1, put a data point. up 2 over 1, data point. Up 2 over 1, data point. Draw a line. Boom. Quantitative velocity graph. All right, how does the motion map look? Here's our position bar. 0 second dot, first second, third second, 5 seconds. See how they're slowly getting farther apart because it's increasing in velocity, and the green are the velocity arrows here. And it's accelerating in the same direction as velocity because we're increasing velocity. Orange arrows are acceleration. And how do the net force arrow and the acceleration arrows compare? Well, they're going in the same direction. They're both going forward. See? Forward to the right, forward to the right. And that's all. You just need to do this again for scenarios 2 through 7, and you'll just keep changing the buttons on the simulation that we talked about. All right, good luck. Thank you.